In the spherical coordinate system, a point, let's call it point P, is described using three variables r, theta, and phi. R is defined as the distance from the origin to the point P. It can also be thought of as the radius of a sphere that is centered at the origin and passes through P. Theta, known as the polar angle, is the angle between positive z-axis and the position vector of P. Phi is the azimuthal angle, which is the angle between the positive x-axis and the projection of the position vector of point P onto the xy plane. The range of R is from 0 to infinity. The range of theta is from 0 to pi radians. And the range of phi is from 0 to 2 pi radians. By using these three variables within their respective ranges, we can represent any point in the coordinate system. It is important to note that while this notation convention is commonly used by physicists and engineers, there is no universal standard across all disciplines. Mathematicians, for example, often reverse the role of theta and phi. In their convention, phi represents the polar angle with respect to the z-axis and theta is the azimuthal angle with respect to the x-axis. To correctly understand someone's use of spherical coordinates, it is crucial to first identify the notational convention they are using. As an engineer, I will adhere to the physicist convention in this explanation. Another intriguing way to visualize a point in spherical coordinate system is to consider the point as the intersection of three distinct surfaces. The variable r defines a spherical surface centered at the origin with radius r, where r varies from 0 to infinity. Theta outlines a conical surface around the z-axis. Theta varies from 0 to pi. For values of theta up to pi, theta forms an upward facing cone. At theta equal to pi by 2, it creates a plane parallel to the xy plane. And for values greater than pi by 2, it forms a downward facing cone. Phi generates a semi-planar surface around the z-axis. This plane is oriented at an angle phi with x-axis, where phi ranges from 0 to 2 pi. A point in the spherical coordinate system is defined by the intersection of these three surfaces. A spherical surface with radius r, a conical surface at an angle theta with z-axis, and a semi-planar surface at an angle phi with x-axis. For finding the transformations between variables r, theta, and phi of spherical system and variables x, y, and z of Cartesian system, following figure with point can be used. The formulas for converting a point from spherical to Cartesian coordinates are x equal to r sine theta cos phi. This represents the x coordinate derived from projecting r to the xy plane and then measuring its x component. Y is equal to r sine theta sine phi. Similarly, this gives the y coordinate by projecting r to xy plane and measuring the y component. Z is equal to r cos theta. This directly calculates the z coordinate based on angle theta. In similar method, we can find out on how to convert from Cartesian to spherical. R equal to square root of x square plus y square plus z square. Since r is the magnitude of the position vector of point P, and this result is from Pythagoras theorem. theta is cos inverse of z by r and phi is tan inverse of y by z. Transformation of point from Cartesian to spherical and from spherical to Cartesian are as per these 6 formulas. So that's it. This video regarding points of spherical coordinate system has come to a conclusion. I hope you got some insights into the subject. Feel free to comment your observations. Thank you. Stay curious, keep learning and keep growing.